Hello everyone. So we are going to start the part A of coarse dispersion. So in this part we are going to deal with the different tests which are applied to detect between or to differentiate between oil in water type of emulsion as well as water in oil type of emulsion. Moreover, we are going to deal with the definition, the source and the descriptive explanation of the emulsifying agents. So what are the emulsifying agents? Those are the agents which help in the formation of the emulsion. So without wasting any time, let's start our presentation. So you see, the detection test, it is very much essential in the pharmaceutical unit operation because the detection test will help you to differentiate between oil in water or water in oil type of emulsion. So the first detection test, it is nothing but it is the dilution test. So the dilution test, it is based on the solubility of the external phase of the emulsions, right? So what we can see, you see, if this is a supplied emulsion, you don't know the type. So if it is a oil in water type of emulsion, in oil in water type of emulsion, if we add more water, you will see there will be no change of the phase. But similarly, if we add more oil to this emulsion, you will find separation of phases because earlier oil was in a low quantity, but upon adding of more oil, the oil will try to have a different phases like this yellow color, right? So in oil in water type of emulsion, if we add water, no changes will be occur, but if we add oil, phase difference will be observed. Similarly, in water in oil type of emulsion, if we add oil to that emulsion, no change will be occur. But if we add water, then separation of the two phases will occur. So as a thumb rule, you can remember oil in water type of emulsion can be diluted with water, whereas water in oil type of emulsion can be diluted with the oil. So this is the first test, right? The second test, it is the conductivity test. So we all know that water is a good conductor of electricity, right? So if we use a source of electricity, if we put two electrodes in a oil in water type of emulsion, you will find, and if these two electrodes, they are connected to a bulb, right, you will find, complete the circuit, you will find the bulb will glow when it is placed in a oil in water type of emulsion because water is present in a high quantity and water is a good conductor of electricity. But the similar apparatus or similar arrangement if we made in a water in oil type of emulsion, where water it is less in quantity and oil is more, the bulb will not glow. So this is the conductivity test. So as we all know that water is a good conductor of electricity, therefore the continuous phase, if it is made up of the water, this water helps the electricity to run more faster and the bulb will glow, right? So this is the conductivity test. The next test, it is a dye solubility test. So suppose if we use any water soluble dye, in an emulsion, so if that emulsion is of water, oil in water type, means water, it is the dispersion medium, right? Water is present in a high amount, right? So if we use any water soluble dye, this water soluble dye will be dispersed throughout the emulsion, where you will find some colorless spot. These are the oil spot, but the dye, it will mix throughout the emulsion in the watery medium. Clear? And if it is a water in oil type of emulsion, so water will be in a droplet form, so there you can find the emulsion will appear, and in this emulsion the colored spot will be observed, which are made up of actually the water. So the water, you will get spots of the dye. So you see example of such, the example amaranth. If we add amaranth and if you see under the microscope, you will see the continuous phase appears red in case of oil in water type of emulsion, right? But in case of water, in oil type of emulsion, you are going to get scattered globules. Clear? So this is the arrangement in the dye test or dye soluble test. The next one, it is the fluorescence test. The thumb rule is that you should remember the oil, they show fluorescence. So thus the oil, it gives fluorescence. So under the UV light, if we observe any emulsion, you see under the UV light, the oil in water type of emulsion, they show spotty pattern. Spots means they will show spotty pattern because the oil, it is present as a globules in the oil in water type of emulsion, whereas in water in oil type of emulsion, it will produce a complete fluorescence because water is present in the low quantity. Clear? So now the next concept, it is the emulsifying agent. So by virtue of the definitions, emulsifier or emulsifying agents are the substances which are added to the emulsion to prevent the coalescence. Coalescence means aggregation or agglomeration of the globules of the dispersed phase. So these emulsifying agents, these are also known as the emulsions or emulsifier, right? So actually these emulsifying agents, they help in the formation of emulsion by basically three basic mechanisms. The first mechanism, it is the reduction of interfacial tension, means it will try to reduce the surface tension, and thus it will induce thermodynamic stabilization in the emulsion. That is the first mechanism. The second mechanism is that the formation of a rigid interfacial film. This emulsifying agent, they will form a rigid interfacial film. Interfacial films means at the interface of the oil and water, which will lead to the formation of a mechanical barrier, and this mechanical barrier will prevent the coalescence. Coalescence means aggregation of the oil droplets. And the last property, it is the formation of an electric double layer. So this surfactant, they will form an electrical double layer, and this electrical barrier, actually it will prevent the coalescence of the particle. Correct? So the pharmaceutically acceptable emulsifier must have some property. Number one, it should be stable. The emulsifier should be stable. It should be compatible with the other ingredients, right? It should be non-toxic. It should possess little odor, taste and color. Moreover, it should not interfere with the stability of efficacy of the active ingredients or active agents, right? So classification of emulsifying agents. So we have a huge classification of emulsifying agents which we are going to cover now, right? So I will give you some tables. These tables I am going to explain you their basic description. So you see the first type of emulsifying agent, it is number one, it is synthetic. So these are also known as the surfactant. It is a surface active agent. So these are synthetic emulsifying agent. The first type, it is the synthetic emulsifying agent, which are the surfactant. They generally form a monomolecular type of film over the dispersed phase. Regarding this monomolecular, we are going to discuss in our next class, where we are going to discuss the theory of emulsification, right? So just simply remember, they are going to form a monomolecular type of film. Example, so synthetic surfactant, example, anionic, we have anionic surfactant. These are which have the pH greater than 8. Example is your soap. Example, potassium laurate. Then in the sulfate, we have sodium lauryl sulfate. In the sulfonate, we have dioctyl sodium sulfosuccinate. Then we have cationic type. Cationic type, we have pH of 3 to 7. Example, quaternary ammonium salt. Then we have non-ionic. In the non-ionic, they have a pH range of 3 to 10. Example is your polyoxyethylene fatty alcohol ester and sorbitane fatty acid ester. So these are the examples. It might be asked during your examination, right? So number two, it is the natural emulsifying agent. The natural emulsifying agent, they generally form multimolecular types of film, right? And sometimes they also forms monomolecular type. It depends. So multimolecular and monomolecular, they form both. So example is your hydrophilic colloids. Example, acacia, gelatin, lecithin, cholesterol. These are the naturally available emulsifying agent. Then we have the finely dispersed Then we have the finely dispersed solid. So solid can be also used as a emulsifying agents, where we are going to use the solid particles. Example, colloidal clay. This is colloidal clay, not colloidal clay. It's a simple typing mistake. It's a colloidal clay. Bentonite, V-gum, metallic hydroxide, magnesium hydroxide. These are the example of the finely dispersed solid which can be used as an emulsifying agent. So now let's discuss some of them. So the first product example of emulsifying agent, let us consider the cetyl alcohol. So this is the cetyl alcohol. So cetyl alcohol, where it is used, principal use. So it is a lipophilic thickening agent. So and stabilizer, it is used for oil in water type of lotion and ointments. The next type, it is the methyl cellulose. What is methyl cellulose? It's a series of methyl ester of cellulose, right? So it is hydrophilic in nature. This methyl cellulose, it is hydrophilic in nature, right? And this is the hydrophilic thickening agents, and it is a stabilizer for oil in water type of emulsion and weak stabilizer for oil in water type of emulsifier, right? The next one, it is your stearic acid. So what is the stearic acid? Stearic acid is a mixture of solid acid obtained from the fat. Chiefly it have the stearic acid and palmitic acid. So it's used, the stearic acid, it is a lipophilic thickening agent and stabilizer for oil in water type of emulsion. Then we have the sodium carboxymethyl cellulose. So it's the sodium salt of carboxymethyl ester of the cellulose. It is used as a hydrophilic thickening agent and stabilizer for oil in water type of emulsion. So most of the emulsifying agents you have seen here, they mostly used for oil in water type of emulsion only, right? The list of emulsifying agents. So these are the list. You can use agar, gallic acid, cetyl alcohol, albumin, diacetyl, tartaric acid, ester. This is also known as the datem. Then this is the casein, alginate, glycerol, monostearate, egg yolk, gum, iris, moss, soap, monosodium phosphate, ox bile, extract, lecithin. You are going to have a list of, abundant list of emulsifying agents that are used in the pharmaceutical unit operation. Let's discuss some of them. So the most commonly used emulsifying agent, it is the lecithin. The lecithin is a non-ionic emulsifier. So you see, what is lecithin? So it is one of the group of phosphoglycerides. So it is found in the various plants and animal sources. Basically, lecithin are available in the egg yolk, nerve tissue, semen, as well as in the cell membrane, right? So these are actually the naturally occurring phospholipid, and they generally, most of the lecithin, they are either extracted from the soybean or they are extracted from the egg yolk. So both, they are oil and water loving. There's lecithin, they act as both hydrophilic as well as lipophilic. So because of this reason, they can be used in a wide range of pharmaceutical products. So lecithin, it is also a vitamin supplement, and it can be used as a dietary supplement. So the most lecithin, they are the most important component of the cell. We know that, right? In the phospholipid bilayer, lecithin is present, as this is there, they are the phosphoglycerides, right? It can also, if you take this lecithin, it can also help to nourish the damages of the cell tissue and also help in keeping the skin soft and supple, right? So it is used in making surfactant. It can be used, this lecithin can be used to increase the flow property of the chocolate, to reduce the cholesterol level in the human being, and it also helps in the cholesterol circulation in the body. So lecithin as an emulsifier or emulsifying agent, it helps the fat and water to stay together. So these are the different products. You can see mayonnaise, right? Most of you are fond of mayonnaise. This mayonnaise, it can be prepared actually by using this lecithin. So good source of lecithin are soybean and egg. So example, egg yolk, mayonnaise, ice cream, milk products, even your cosmetics, they also have the lecithin. Lotion, cheese, margarine, and coating. This coating means the paint. These all have the lecithin, right? The next example, it is your soap. So what is soap? We all know that soap, these are the salts of fatty acid, right? The soaps or detergents may be anionic, cationic, or non-ionic, right? So the soaps, they are also known as the amphipathic. Amphipathic means they have two regions. One end sticks to the oil, that is the tail region. It is also known as the hydrophobic end, whereas the other end, it sticks to the water, that is the head. It is the hydrophilic region, right? So the soap or synthetic detergent, they contain, we know that they contain a long non-polar tail and a ionic polar head. And what happens whenever you just use this soap, right? The non-polar end of the molecule of the soap molecule, it dissolves well in the in the non-polar grease or oil area, right? And the ionic head, it dissolves in the water. Does this tail of the soap, it help this soap molecule, it penetrates into the oil region or into the grease and break them up in the micelles. So this concept, it is used to decrease the surface tension in the dispersed oil globules, which are used in the formulation of the emulsion, right? So example of soap, cationic soap, example quaternary ammonium salt of acetates, chlorides and bromide. Anionic, example sodium alkyl sulfate or sodium alkyl benzene sulfonate. Non-ionic soap, you have the detergent. These detergents are esters of the alcohol, that is cetyl alcohol having high molecular mass, right? Example polyoxyethylene, fatty alcohol ethers, they are the example of non-ionic. Then we have the diacetyl tartaric acid ester. This is also known as, this is an example of non-ionic surface emulsifier. It is also known as the DATEM, DATEM. So it is also known as the DATEM. So DATEM, it is used to strengthen the dough, which is used for preparation of what? Bread. So it actually builds a strong gluten network. Gluten, I hope you know what is gluten. It is present in the food, right? So it is a emulsifier that is used in the baking process. So it is used in enlarging the physical volume of the bread. It improves the texture of the bread tissue. It increases the shelf life, as well as it increases the soft feeling and pliability of the bread. So it is used in the crusty bread, chewy texture, biscuit, coffee whitener, ice cream, salad dressing, etc. So this is the DATEM. It is used everywhere, right? So the DATEM appears to interact with the hydrophobic part of the gluten, and it does help actually, it helping in the protein unfold and forms the cross-link structure. So this DATEM, it is used as an emulsifier, as a dispersion agent to improve the emulsification as well as intermiscibility between the oil and water, right? So the dispersive, actually this DATEM, it is dispersive in hot water, soluble in oil and fat or some kind of organic dissolvent. So this DATEM, it is also used in the butter to make the taste better. The next one, it is the gum. So where we use the gum? See, by virtue of the name, the gum, we all know what is the gum. So gum helps in the, actually it helps in the, as a binder. Actually it prevents the coalescence of the oil globules. So gum, it may be cationic, non-ionic or anionic. Example is your xanthan gum. It is an example of anionic and it is natural. Cationic gum, it is the guar gum. It is cationic guar gum, these are semi-natural, right? And guar gum is also non-ionic, which is natural one. So natural guar gum is non-ionic, semi-natural guar gum is cationic. An example of anionic, it is anionic gum, it is the xanthan gum. So the gum are actually the hydrocolloidal. They helps in the binding, thickening and emulsifying the gluten-free ingredients. So this guar gum, it is an emulsifier, right? So it is also used as a thickener. It is also used as a stabilizer, and it is used in a wide range of food, cosmetics and pharmaceuticals, right? So it helps in the thickening without application of the heat. That is its most effective use. Without application of the heat, the gum, it helps in the thickening of the substances, right? So it can act as a light emulsifier, and it prevents the oil droplets from coalescence, this gum. So it's also acts as an emulsifier. So this gum, actually it is soluble in both the cold and hot water. Moreover, this gum, it is resistant to oil, grease and solvent. It have a high viscosity, right? It is functional even at the low temperature. Means if the product, it is freezed, even the gum will be working as a emulsifying agent, and it is a better thickening agent, right? So in baking, In the baking process, it increases the dough yield. In the dairy product, it thickens the milk, yogurt, liquid cheese product, and for meat, it functions as a binder, this gum. So it is used in a dry soup or sweet dessert or frozen food item. So guar gum, as a water soluble fiber, it acts as a bulk forming laxative. So it can claim to be effective in promoting the regular bowel movement and relieving the constipation, right? So example, lotion, surfactant product, conditioner, ice cream, cosmetics, baking food, everywhere we are going to use this gum as a emulsifying agent. So I hope you have enjoyed the class. If you like the video, just press the like icon. You can share this video. You can subscribe to my channel. Thank you once again.